Hi everybody, hope everyone's doing well. Today we're going to look at an example of a proportion hypothesis testing problem. In the future, probably tomorrow, I'll post a video on sample means significance testing, which is very similar to what we're doing and what we've been doing over the last 2 weeks. However, there's one new thing with degrees of freedom, but it's not too bad, so we'll look at that in the future. So let's look at this question. According to a simple random sample of 124 elevator users, 83 step out of the elevator with their right foot. A researcher believes that most people do this too. Is this convincing evidence that people step out of an elevator with their right foot? Okay, so this is a clear claim. And what we need to do is find a z-score to either reject or fail to reject the null hypothesis. First of all, let's start with the null hypothesis here. H naught. So the person's claim that most people step out with their right foot. So it's probably easier to look at the alternative hypothesis first. Most people will be p of greater than 0.5. The reason why it's greater than 0.5 because that would show a bias to one foot or the other foot, in this case the right foot. So the alternative would just be the status quo, a 50-50 shot. Either left foot or right foot. So we'll do p equals 0.5. Alright, let's go back to the problem. 124 is our n, so let's write that down. And let's calculate our p hat or sample statistic. So n is 124. 83 people step out with their right foot. So we can calculate p hat out of that. 83 out of 124, which is a decimal, is 0.669. So before we can do this significance test, we need to check those three criteria to see if we can run this test or not. So let's remember what those were. One was the random sample. Is the problem random? Yeah, it checks out that it's random because in this situation, a random sample was picked. The 10% criteria. The 124 elevator users is definitely smaller than 10% of all elevator users. Okay, so it's kind of tricky to write with this pen here, but it'll get better in the future. Okay. And the last criteria, so let's put a check mark by that. And the last criteria was NP has to be bigger than or equal to 10, and n times 1 minus p has to be bigger than or equal to 10. So remember from the problem, p is 0.5, let's write that down. So n from the problem was 124. So n times p, 124, times 0.5 is definitely bigger than 10. It's actually going to be 62. Is greater than or equal to 10. So that checks out. Let's check 1 minus p. So remember, p is 0.5. So 1 minus 0.5 is also 0.5. So and our n is the same. So 124 times 0.5. It's going to give us the same answer. 62 is greater than or equal to 10. And that checks out. So now we can do our calculation. So remember, the formula we're going to use for our z-score is z equals p hat minus p naught. Remember, p naught is the same thing as p of r null hypothesis over the square root of, it's going to be p naught and 1 minus p naught over n. So when we plug in those values, what we're going to get is 0.669, that was our p hat, minus 0.5 of the square root of 0.5, 1 minus 0.5 is also 0.5, over 124. And that's 3.76. Now what does this mean? So now what we have to do is go back to our alternative hypothesis. So H alternative was P is greater than 0.5. So that's going to be this tail over here, the right side area. But if you can recall, the z-score table that you have in your book or chart that you have tells you the left tail. So we have to do that trick. We have to do 1 minus the z-score area of 3.76 to get our p-value. Okay, so if we look up the z-score of 3.76, let's check and see what that is real quick. That will give us a very, very high value. It's going to be 0.9991 approximately. So we're going to do 1 minus that area. Which is approximately going to give us 0.0001, which is definitely smaller than alpha. Because remember, what's this? Type a quote here. Johnny Appleseed. Okay, guess I'll type a quote here. Don't know if Johnny said this or not, but highly likely that he did. And those were good apples. All right, there you go. So, where were we here? Okay, so that, yeah, alpha we had was 0.05. And that was selected from the start. Actually, did we not select it? No, I guess not. Yeah, it's okay. So this is the alpha we're comparing our p-value to. All right, so the p-value we calculated was 0.0001. So that is definitely smaller than 0.05. So we can reject the null hypothesis. One extra L in there. So we can say that most likely most people step out with their right foot based off this data. All right, I'll see you later.